All right, what is up, you guys? This is the hugest, biggest, most fun lesson of the unit circle, day one. I'm gonna give you some background of how the unit circle even begins, and then how you draw it. So some background that you need to know is this thing called a reference angle. Reference angles are the acute, so less than 90 degrees, that's what acute means, angle between the terminal side of an angle and the x-axis. It's always positive, denoted by that. What's the terminal side? Well, actually, okay. When we're drawing angles, going positively is going this way. If you're like, okay, so if we're going, this would be positive 90. It's like these are virtually in right angles. So it's like, if I'm drawing, this would be positive 90, positive 180, positive 270, positive 360. I get all the way down and I make a circle. It's 360 degrees. Virtually, if you're going the other way, then if you're going down, see how I wrote down was negative? Negative 90, negative 180, negative 270, negative 360. What is a terminal side of an angle? That's if I go an angle like here, make this maybe 160. This is the terminal side. The initial side is always right here. The initial side is always this positive x-axis. So the terminal side is how far you go. If I went negative 160, this would be the terminal side. So it's where the angle ends up is the terminal side and the x-axis. This will be important later on. And the reference angle is this little part in between here, or this little part in between here. It's always positive, and it's denoted by theta with a little. This will make more sense later on. I just needed to tell you what a reference angle is. I also wanted to practice drawing angles in general. So 320, it's positive, so I know that I'm gonna go this way. I know I'm gonna start up. Sorry, there's a hair there. Positive 90, positive 180, positive 270, and then I know that if I go all the way here, it'll be 360. So you just kind of make a little 270 to 360, maybe that's right here. Doesn't have to be exact. This would be the terminal side. That would end up being 320 drawn, roughly. This little part right here, this would be the reference angle. And it would be equal to 40 degrees. Because we went 320, this little part would be 40 degrees. Yeah? Negative 175. So I have to go down now. So I go negative 90. Negative 180 is at that line. So I'm going to almost go to that line. An angle going like this, sweeping like, would be at negative 175. And this little guy is the reference angle. And remember, it's always positive, so it's not negative 5. It would be 5 degrees, I guess. Yeah? What about this guy, 220? So we got 90, 180. If I go all the way down here, it's 270, so it's like somewhere in between 180 and 270. Again, it doesn't have to be exact. Now, that's it drawn. The reference angle is not this way. Remember I told you it's from the terminal side to the x-axis? It's always the shortest distance. So it's not here. It would be here. That would actually be the terminal side. 40 degrees. Okay? Because 220 to 180. So it's always back to the x-axis, and it's the shortest distance. So that is reference angles. That is something you'll need to understand about the unit circle when we're doing things with the unit circle. Now the actual unit circle. I drew a bunch of circles on it. So the unit circle is centered at the origin. It's this little cute thing somebody figured out, and he's centered at the origin, and he has a radius of 1. So if you're centered at the origin, and your radius is 1, these points would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Just points on a graph. That's something to know. But so yeah, the unit circle is centered at the origin, has a radius of 1, and it has those points. We're going to be talking about these points. They're called quadrantal angles later today. Woohoo! Okay. Let me unclip this here. Now, yesterday we were talking about, sorry, let me clip it back in. No, I do want this clipped in. I didn't want it to write over my handwriting, but I do want it clipped in. Okay, yesterday we were talking about special right triangles. Those are that 30, 60, 90 triangle or the 45, 45, 90 triangles. You learn them in math too. And this one comes from an equilateral triangle that's 60, 60, 60 cut in half. And this one comes from a square with all 90 degrees cut in half. And then we work the side lengths. What happens is we put these special right triangles into the unit circle, in each quadrant of the unit circle. Oh, which also, it's maybe something I should say. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. It actually goes counterclockwise as it grows. So when I refer to quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? Beautiful. Beautiful, beautiful. I'm going to hold up the video right here, and you could pause it and maybe get that first page of notes. I'm going to post them too, but I don't know. And this is what I have written for the blank page of notes. And then we're going to get into it. So if you wanted to pause the video and write what I have for the blank page and then fill in as I go. But special right triangles in the unit circle. So we put the special right triangles into the unit circle. That's where the unit circle comes from. Remember how I told you that the radius is 1. So looking down here, if I'm putting in the 60 degree, this triangle, the 60 degree triangle in here, into the unit circle. And if the radius is 1 of the unit circle, that means from here's 1, here's 1, here's 1, here's 1, here's 1. Anywhere from the center out, any line is the radius. So technically that means this piece has to be equal to 1, right? But up here, that piece is equal to 2. The hypotenuse of this right triangle is equal to 2. We need it to be equal to 1. How do we get 2 to be equal to 1? Well, we could divide it by 2. 2 divided by 2 is 1. If we do it to one side, we have to do it to other. Wait, that's mathematically sound. We have to make all of them divided by 2. So this becomes 1 now. So now when I put this triangle in the unit circle, this is really 1. It's now as 1, right? Then this little length is 1/2, and this length is root 3 over 2. That length is root 3 over 2. This length is 1/2. I'm just putting that triangle in. These values will be important. Okay, we want to do the same thing for the 45 degree triangle. So the 45 degree triangle, we again need this piece, the hypotenuse, to be equal to 1. How do we get root 2 to be equal to 1? Well, divide everything by root 2. Root 2. Then root 2 over root 2, now that's equal to 1. We're good. Woo! Also, I apologize for my nails. They are so gnarly, but no nail salons are open in Corona. So, like, what? Anyways, 1 over root 2. Remember, we learned how to rationalize the denominator yesterday. This is why I wanted to teach you that. Remember, you have to multiply. If you have 1 over root 2, you have to multiply by root 2 over root 2. You multiply whatever the bottom is. 1 times root 2 becomes root 2. Root 2 times root 2 just gets root 2. So this actually is equal to root 2 over 2. And this is root 2 over 2. You'll learn to memorize that. Like 1 over root 2 is just root 2 over 2. It's just another way to write that. So the hypotenuse is now 1. This little distance, aka this distance, is root 2 over 2. And this distance, aka this distance, is root 2 over 2. We kind of just, fit our triangles into the unit circle. We had to split them up and put them into the unit circle. Now, here. This is important because I'm gonna flip back over here now. I'm gonna flip between both of them. When we drew this, now this particular point on the unit circle, remember how points go x, y? Like if I was graphing the point 2, 1, we'd go over 2, up 1. So this point is really 1/2 root 3 over 2. Yeah? That is a point on the unit circle. What about with this 45-degree triangle? This point would be root 2 over 2, root 2 over 2. Okay? So now we have points on the circle. If you guys aren't absolutely grasping this, no big deal. I just want to show you where the unit circle comes from. Then, so if we flip this triangle 45 or 45, it doesn't matter because they're both 45. This triangle, if we flipped this guy like this, it'd almost be like, we went, and put the 30-degree in here, then it would actually be this distance is root 3 over 2, and this distance is 1/2. So I'm just taking it from here and flipping it. So this point is then root 3 over 2, 1/2. If you guys are like, what is this lady talking about? We're going to get there because what the unit circle is, what it is these 3 triangles put into the 4 quadrants. So technically, these 3 triangles are drawn every time into these 4 quadrants, and there's these 3 points in every quadrant. Okay? So it's literally would be like this. It'd be like this is the unit circle. There's the 45-degree splits it perfectly in half, so this one's the 45-degree point, right? And he is root 2 over 2, root 2 over 2. Then the 30-degree would be a little bit less than 45, so it would be roughly here. And that point of the unit circle would be, as we said, root 3 over 2, 1/2. And then the last one is the 60-degree triangle drawn in, be like roughly here, right? And that point would be 1/2 root 3 over 2. So basically, the 3 triangles, the special right triangles, are cut to fit into the unit circle, and then they're really drawn, and there's those 3 points. Then those 3 points go to each part of the unit circle. Yeah, that's what it is. That's how you make it rock, people. And now, think about this. If I have a point in the first quadrant, they're both positive. I made the point 2, 1. Just randomly, I made the point 2, 1. When it goes into quadrant 2, the x value goes negative because x goes -2, +1. Then when we're in quadrant 3, they're both negative because it's negative, negative, -2, -1. And any point in quadrant 4, the x will be positive and the y will be negative. Guess what you do with all of those points? Well, I follow the same pattern as this. Oh, sorry. If I have, excuse me, if I have the 60 or the 45-degree, or what did I put here? Root 3 over 2. I put the 30-degree triangle right here. Oh yeah, that's why I drew an arrow, I guess. If I have this 30-degree triangle in quadrant 1, then the point here would be negative root 3 over 2, +1/2. I just make the x negative. This point down here would be negative root 3 over 2, -1/2. And this point would be positive root 3 over 2, -1/2. So the points then are just follow the same pattern as the other points, the negative signs, you can put them in. So you can end up filling up the whole points on the unit circle just by thinking, if you memorized quadrant 1 and then you flipped it to all the other quadrants. And furthermore, there's a little cute pattern. They're all divided by 2, yeah? If you're going on the x, it ends up going 3, 2, 1. And then on the y, it goes 3, 2, 1. And you have to remember the 3 and 2's have square roots. Like x's are maybe getting bigger. Y's are getting, I don't know. You could play with the numbers to figure out how to memorize that. So that is how the unit circle is really formed. Is it literally is taking the special right triangles and putting them into the unit circle in all the quadrants. And we are going to eventually have it look like this. Ooh, see how all the points are in it? 3 triangles? Yeah, we'll eventually get there in the next video.